Welcome to the Physics Basics. Hopefully you enjoyed our last video. We're going to go into some more things today. Today what you're going to learn about is how to determine the uncertainty of a measurement and how to do simple math using scientific notation. Well, let's get started here. Measurement. Certainty versus magnitude. Well, I guess I forgot to take off this page too. But the moon rising at 7:15, that's a certainty. They can calculate that. They know exactly the geometry behind it. That's going to be a certainty. The moon is going to rise at 7:15, just because it is a calculated value. Your friend picking you up at 7:15, that is a magnitude, meaning 7:15, 7:16. It's not the same. So you can't be certain that they're going to be exactly there at 7:15. So it's just a magnitude. And we're going to learn and continue talking about the differences of those. Well, here I've got page 3 again. But the uncertainty was measured at 11.4 plus or minus 0.1 centimeters. Now, there is an uncertainty here because we are uncertain if it's exactly 11.4. We're giving ourselves an arrangement here of error. We're saying that we could be off by 0.1 centimeters. So we're still pretty exact, but we are giving ourselves a little bit of leeway here. And that limit of uncertainty is 0.1 centimeters. So what I want you to understand is that this is the limit of uncertainty here. Accuracy. Accuracy is a method that we use and we compare it to yourself. How accurate? Well, you know, uh, uh, a shotgun is more accurate, for example, than a nuclear bomb blast. Does that mean that a shotgun's highly accurate? Well, it's what you compare it to. If I compare it to a rifle with a high-powered scope on it, it's probably not nearly as accurate. But it's always relative to what you're comparing it to. So up here, if we take our limit of uncertainty, this plus or minus 0.01, and compare it to the size of the object that we're measuring, we find out that our uncertainty is only 0.9%, not 90%, less than 1% inaccurate. We have a chance of being here. So this is a fairly accurate measurement because this object is so much larger than our uncertainty. So that's how we would go about calculating how accurate something is. Let's talk about scientific notation right now. 3.24 times 10 to the fourth and 5.4 times 10 to the third. What I like to tell students is think about this. Forget about this 0.24 right now. We're going to forget about this 0.24. And forget about this 0.4 right here. And let's make this times 10. Let's just make it x. So we're going to treat it like it's 3x to the fourth and 5x to the third. Well, how would you do that? In algebra, you learn to multiply the coefficients, and you got 15. And then when you had like bases, the x's are like, you added your exponents. Well, the 3.24, let's go back here and let you see those again. The 3.24 and 5.4, those are your coefficients. So we're going to multiply those. And the times 10 and times 10, those are like bases. So that means we can still just go about adding the exponents. So I'm just going to take 3.24 times 5.4, and when I multiply that, that gives me 17.496. 10 to the fourth, 10 to the third, that gives me 10 to the seventh. And that would be our answer, except it's not in scientific notation. This is a correct answer, but it's not in scientific notation. We would need to take this decimal, move it one spot over, and it becomes 1.7496 times 10 to the 8th. When it comes to dividing, we do the exact same thing, except we divide the coefficients and we subtract our exponents. So let's look at some examples of this. Let's start up here at the top, and I'm going to use my calculator for some simple math. I'm not going to try punching in the times 10 to the fourth or the 10 to the third. Right here I can look at this and say that 10 to the fourth and 10 to the third, that's 10 to the seventh. So then it really becomes, what is 1.34 times 5.1? And that turns out to be 6.834. Now I don't need to do any other changes to it because I've only got one number to the left of my decimal point. I'm going to go down here and do the bottom one. 10 to the fourth, 10 to the third. Well, when I divide, I subtract my exponents. So I know this is going to be times 10 to the first. And now it just becomes 3.2 divided by 5.4. And that gives me 0.59 and so on times 10 to the first. Well, this is not really in scientific notation. I'm going to move it one spot to the right, and that becomes 5.9 times 10. This now becomes from a 1 down to a 0. And we could probably go a little bit farther with this. In algebra, you've learned anything to the 0th power is 1. So this really becomes 5.9 times 1, or just 5.9 would be our final answer here. Now I'm going to go ahead and pause this, and I want you to do the ones on the right. All right, as you can see here, I've went ahead and already put the answers in. Hopefully you've already put those into your notes. I want to remind you that when you come in tomorrow on your notes and discussion page that you have to have 2 problems worked out, and you need to have 2 questions or discussion topics filled in as well to help us have a better discussion. I got a feeling some of you are going to have some questions maybe about scientific method, and that's fine. That's what we'll spend some time discussing there in class tomorrow. Hope you enjoyed this short little lecture. We'll see you tomorrow.